a faucet is dripping once per second, how many showers does that equal over the course of a year? So over the course of a year, if a faucet drips once per second, how much water equivalency to a shower is that going to equal? So our answers are 300 showers, 180 showers, 65 showers, or 10 showers. Looks like 300 and 180 are coming in pretty close. Pretty fun to watch this kind of move back and forth. So we're going to go ahead and stop the polling right there. And so we have about 58%, 58% with the 300 showers, 38 for 180, 3% said 65, and no one said 10. The correct answer is actually 180 showers. So we can see that that really adds up with those leaks as they come through there. And so great transition into the subject of leaks. So, there are ways that we can implement practices and policies to reduce our overall water consumption, but really leaks are a great way to start, especially when we look at the camp facilities and infrastructures, which are typically pretty old and dated. And so this is a great place to start. So we're going to talk about some leak facts and statistics, reading our meter bills, checking for toilets and faucets. And so to define a leak, we're basically looking at water that's wasted with no intended use or purpose. Once we identify a leak, they should be the first area to target from a water management perspective. And the benefits of addressing our leaks are we're going to save money, save water, save time, and expenses that would otherwise be associated with unmanaged leaks. So according to the U.S. EPA, on average, leaks can cause almost 10,000 gallons of wastage in a home every year, and this amount is sufficient to fill a swimming pool. It's nice to have those visual perspective of what those statistics look like. Numbers can really only go so far, so having an image supplied next to that is pretty helpful. So our most common issues of leakage are dripping faucets, leakage in toilet flappers, or leaking valves, and all of which can be easily fixed. And with the dripping faucet, which we talked about previously, fixing that can save almost 10% of a homeowner's water bill. So we can see that there's environmental as well as economic incentives for following through with these. So we'll start with reading the meter bill. Now, a lot of utilities are moving to digital meters, similar to our energy meters that are going to be read digitally, and you don't have to have a meter maid coming out to actually read it. But good just to understand the general idea of what a meter looks like and how we can gather that information. So the first arrow points down to the dial. The dial rotates when water passes through the meter. One full rotation equals 1 cubic feet of water, or 7.48 gallons. The next is the low flow indicator, and we can see that the little red one, the next arrow there. And this low flow indicator rotates with very little water movement. So any water moving through the meter is detected, so even small leaks will register. And then finally is the odometer, similar to what we see on the car. The water meter odometer records water use in cubic feet and displays as follows. The digits from right to left represent 1, 10, and 100 cubic feet, and so on and so forth. And so like a car, the water meter odometer cannot be altered. And so this is how we're able to gather data about our water usage. So what do we do with this? So if you're looking at a meter, one way to kind of estimate our water usage is to read the odometer and write it down completely and write down the date that you read it on. After a period of about a week or 7 days, read the odometer again, write the date down. And then to figure out what your water usage in that time is, subtract the first from the second reading, and this is your water use in cubic feet during that period. If you multiply that by 7.48, you'll figure out the gallons used during that period. And then finally, if you divide the water used in gallons by the number of days between the reading, you'll get your average gallons per day during the period. So the benefit of being able to read our meters is as we go in and we implement changes, so whether we're fixing those leaks, whether we're putting low flow shower heads, or any other number of water saving, water efficient devices, we can start to quantify the change that we see by implementing those new initiatives there. So other ways to watch for leaks, if you turn off all indoor and outdoor water sources, then you can go to the meter and look at that low flow indicator. If it moves, this may mean that a leak is indicated in an appliance or a pipe. If the meter shows no obvious movement, then it's a good chance there is not a leak, but you could also return a little bit later and see if there's any change. And so basically you're closing off all your water. If there is a leak, that water main is going to let more water in to fill that back in again. So that's a way that we can use our meters there. So the flapper valve is a very common issue with toilets, and it's causing leaks that we might not be aware of. And so in the diagram to the right, you can see the blue flapper there. So just to give us a little kind of up close and personal with the innards of a toilet there, if that flapper is old or is hardened or has leaks or corrosion or anything that's allowing water to escape through there, that water is going to escape into the bowl, and then your fill valve is going to automatically fill that water up again. So one way to test to see if that flapper the seal is good on it is to squeeze a few drops of food coloring into the bowl and then wait approximately 15 to 25 minutes and then look into the bowl. If you look in the bowl and you see no color in there, then your flapper is good. If you see color in there, that means that there's a leak in there. And then you can alert your maintenance or support staff to inspect it and see if it needs to be replaced. Just a simple, easy activity that we can do. And again, it might not be, as Avi said, it might not be a sexy thing, or I think Seth mentioned as well, changing out the low-flow shower heads, but it really does connect our campers with what we're doing and understanding the impact of this. And maybe they'll take these ideas back to their home communities and implement them there. And so we'll also look at faucets. So faucets was another high area of water leakage. And here we see the sink faucet, a diagram there. And there's several different areas that can cause that faucet to leak. And, we're not all plumbers, and that's okay. And so one thing that I really recommend, and I think Avi and Seth both touched on, is the importance of signage. Signage can be a really good way to communicate information to our visitors and guests and campers and staff. And so put up a simple report all leaks immediately sign. The sooner a leak is identified and fixed, the less water is going to be wasted. And then also making sure that you have a system within your maintenance plan to make sure that those leaks are addressed in a quick manner there.